Spring, 1944. Somewhere deep inside Germany, under a gray morning sky, a train clatters across cold rails. On one of its flatbeds rests a shape wrapped in canvas, sleek, silver, and wounded. A captured American fighter. When the covers are pulled back, the Luftwaffe officers stare in silence. The sun glints off smooth, unbroken aluminum. Along its fuselage, faded white stars of the United States Army Air Forces. A P-51 Mustang, intact. Mechanics from the Rechlin test center circle the aircraft like surgeons before an operation. They run their gloved hands along the wings, tracing rivet lines, studying the unfamiliar shape of the laminar flow design. Then slowly they unbolt the cowling. Inside lies the heart of the machine, a Packard-built Rolls-Royce Merlin engine, phrasing 600 horsepower of precision and endurance. The German engineers exchange looks. The smell of oil and hot metal still lingers. In that quiet hangar, surrounded by the crumbling remains of a war once thought unstoppable, a realization begins to form. Germany's air supremacy had already ended. By late 1943, the sky over Europe had become a graveyard of ambitions. For years, the Luftwaffe had ruled the air, fast, disciplined, and unmatched. From the blitzkrieg over Poland to the burning skies of France and the Balkans, the black crosses of German aircraft marked superiority through precision, doctrine, and engineering. But as the war stretched into its fourth relentless year, the tide of air power had begun to shift. The United States Army Air Forces, newly confident and increasingly mechanized, were arriving in strength. Heavy bombers, the B-17 Flying Fortress and the B-24 Liberator, thundered across the English Channel in endless formations, their mission simple but devastating: to burn the industrial heart of Germany from above. The strategy was daylight bombing, a method the British had abandoned after catastrophic losses early in the war. Yet the Americans insisted it could be done, provided their bombers could fly in tight formations and defend themselves with concentrated firepower. It was a bold plan. But in practice, the reality was brutal. Every mission into German airspace was met with waves of Messerschmitt Bf-109s and Focke-Wulf 190s. Bombers fell by the dozens. The sky over Schweinfurt and Regensburg turned black with smoke and burning aluminum. Loss rates climbed beyond sustainable limits. Without long-range escort fighters, the USAF was bleeding itself dry. Across the Channel, engineers and strategists wrestled with a question that might determine the course of the war. How do you escort bombers all the way to Berlin and back? Early attempts failed. The P-38 Lightning, though fast and powerful, suffered from unreliable engines at high altitude. The P-47 Thunderbolt was rugged but drank fuel too quickly. British Spitfires, magnificent in combat, simply lacked the range. The Allies needed something new, a fighter that could fly deep into Germany, fight on equal terms with the Luftwaffe, and still bring its pilot home. In 1940, before the United States even entered the war, the British Purchasing Commission had approached North American Aviation with a request. They wanted the company to build Curtiss P-40s under license. But James Dutch Kindleberger, the company's president, countered with a daring proposal. Instead of building someone else's fighter, why not design an entirely new one, faster, more efficient, and cheaper to produce? North America's engineers accepted the challenge. In just 117 days, the prototype, the NA-73X, took flight. It was sleek, streamlined, and unlike any other fighter in service. But its engine, the Allison V-1710, limited its performance at high altitude. The early Mustang was fast, but it lacked the lungs for Europe's air war. Then came the turning point, one of the most important transatlantic collaborations in aviation history. British engineers realized that if the American airframe were fitted with the Rolls-Royce Merlin, the same engine powering the Spitfire, the results could be extraordinary. When the first Merlin-powered Mustang flew in 1942, test pilots were stunned. It climbed faster, flew farther, and handled beautifully at altitude. The laminar flow wing, a cutting-edge aerodynamic feature, reduced drag dramatically. Combined with drop tanks, the Mustang could escort bombers deep into enemy territory, far beyond what the Luftwaffe expected. The transformation was complete when Packard Motor Company in Detroit began mass-producing the Merlin engine under license. The result: a perfectly balanced marriage of British design and American industry. By the end of 1943, The P-51B and C models began arriving in Europe. Their appearance over the continent marked a new chapter in the air war. Sleek, long-legged, and deadly, the Mustang was everything the Allies had hoped for, and everything the Luftwaffe had feared. In briefing rooms across Germany, reports of a new American fighter began to circulate. It could dive faster than a 109, climb with a 190, and fight at altitudes the Germans had once considered safe. Pilots who encountered it returned shaken. Adolf Galland, the famed Luftwaffe ace, would later admit, "When we saw Mustangs over Berlin, we knew the end had come." But before that grim realization could settle in, the German High Command wanted proof. They needed to understand why this new enemy aircraft was so effective, what made it superior. And so, when the first P-51 was forced down inside German territory, it was not destroyed, it was carefully recovered, examined, taken to the Luftwaffe's test and research centers. Inside its metal skin lay answers that Germany desperately needed, and truths it did not want to face. The captured Mustang, that would change German understanding of the air war, came down in early 1944. It was not destroyed by flak or in a mid-air explosion, and it was forced down intact after battle damage and fuel loss, a rare gift in a sky littered with wreckage. Luftwaffe recovery teams moved quickly. They knew what they had. The aircraft was transported under heavy guard to one of Germany's top evaluation centers, Rechlin, near Lake Müritz, the Luftwaffe's equivalent of Britain's Farnborough or America's Wright Field. Here, the Reich's best engineers and test pilots examined captured Allied technology, from B-17 bombers to Spitfires and P-38s. But none stirred more curiosity, or quiet apprehension, than the new American fighter, the P-51 Mustang. The timing could not have been more desperate. In early 1944, the Luftwaffe's strength was collapsing. Allied bombers came by the hundreds, then by the thousands. The once proud Jagdgeschwader wings were shrinking, fuel shortages grew severe, replacement pilots were younger and less trained, and the skies were now thick with contrails of enemy aircraft. On paper, Germany still possessed remarkable machines: the Bf-109G, the FW-190A, and soon the revolutionary Me-262 jet. Yet numbers told a cruel truth. There were too few of them, too late and too often grounded by fuel, spare parts, or shattered airfields. The arrival of the Mustang turned a difficult situation into a catastrophe. Until then, German defensive strategy had relied on attacking bomber formations before their escorts arrived, or after they turned for home. The P-47 Thunderbolts and P-38 Lightnings that flew escort could not follow all the way to the target. There was always a vulnerable gap, a deadly window where the bombers stood alone. The Mustang erased that window. With external fuel tanks, it could fly from England to Berlin, fight and return home, something no previous Allied fighter had achieved. Suddenly, Luftwaffe interceptors could no longer climb into battle with impunity. Wherever they appeared, the P-51s were already there, waiting. German pilots felt the change instantly. Veterans who had once stalked unescorted bombers now found themselves hunted. The Mustang's speed in a dive was lethal. Its range meant it could linger over German airfields, ambushing fighters on takeoff or landing. It wasn't just an escort, it was a declaration that the Allies owned the sky. Back in the laboratories and hangars of Rechlin, the engineers began their work. The captured Mustang was carefully stripped, documented, and photographed. They noted the precision of the rivets, the aerodynamic smoothness of the wing, and the simplicity of its systems. When the cowling came off, they found the Packard-built Merlin, a machine both familiar and foreign. It was, in essence, a British Rolls-Royce design, yet built in America with industrial consistency that astonished the examiners. Each cylinder head, manifold, and bearing showed uniformity, no file marks, no adjustments needed. One German engineer reportedly remarked, "It is as if every part were born perfect." The Luftwaffe's own engines, such as the Daimler-Benz DB605 powering the Bf-109, were elegant and powerful but delicate. They demanded meticulous tuning and constant maintenance. The Merlin, by comparison, was robust, efficient, and forgiving. It could sustain damage and still bring a pilot home. In testing, German pilots confirmed what their enemies already knew. The Mustang was fast, stable, and deadly. It accelerated smoothly, handled beautifully at altitude, and maintained control even in steep dives where their own aircraft often suffered compressibility problems. But what unsettled the observers most was not just its performance. It was its purpose. Every inch of the Mustang served a coherent strategy. This was not an aircraft built to dominate a front. It was built to end a war. At Rechlin, the reports began to circulate upward through the Luftwaffe's command structure. The tone was clinical, but between the lines was quiet resignation. The Mustang represented something Germany could no longer match: the fusion of design, production, and logistics into a single, unstoppable machine. And as engineers filed their technical notes, pilots on the front lines were living that truth in blood and fire. The war in the air was now entering its decisive phase, and for the first time, the outcome was no longer in doubt. The engineers at Rechlin would soon discover why. The technological angle to the German engineers who disassembled the Mustang's heart. The discovery was not about mystery, it was about mastery. The Packard-built Merlin V1657 engine was, at its core, a study in industrial precision. Every bolt and casting spoke of a production system working at full efficiency, something the Reich no longer possessed. In a war where materials were scarce and factories bombed nightly, the Americans could produce thousands of engines, each virtually identical in quality. The Merlin's two-stage, two-speed supercharger impressed the Germans most. It gave the P-51 both high-altitude power and low-altitude efficiency, solving the performance problem that had limited many earlier engines. Where the Daimler-Benz DB605 needed delicate handling to maintain boost pressure, the Merlin seemed effortless. Its integration with the airframe was seamless. The cooling system, the ducting, the propeller pitch, all working as one synchronized organism. They measured the laminar flow wing, noting its subtle curve and minimal surface roughness. The concept was elegant: reduce drag by allowing air to remain smoothly attached to the surface longer. Germany's engineers understood the theory. They had experimented with it. But they were struck by how effectively the Americans had realized it in mass production. This was not genius in isolation. It was genius industrialized. For Germany, locked in a war of attrition, that was the most terrifying revelation of all. The tactical angle: to understand the Mustang's true significance, one must look beyond the laboratory, to the skies above Europe in 1944. Before the P-51, the U.S. 8th Air Force had suffered catastrophic bomber losses. Operations like Schweinfurt, Regensburg, and Munster nearly broke the daylight bombing campaign. Entire squadrons vanished before reaching their targets. Pilots knew that once they crossed into deep Germany, they were on their own. But by early 1944, new squadrons of P-51s began appearing alongside the bomber streams. At first, Luftwaffe pilots mistook them for P-47s. They soon learned the difference. The Mustang could escort bombers all the way to Berlin. It could also leave the formation, sweep ahead, and engage interceptors before they ever reached the bombers. This flexibility changed everything. German fighter tactics, that built around massed frontal attacks, began to crumble. The Luftwaffe could no longer dictate the terms of battle. The Mustang's range, speed, and climb rate allowed American pilots to hunt German fighters in their own airspace. By mid-1944, Allied pilots were loitering over Luftwaffe bases, shooting down aircraft as they took off or landed. For the first time, Germany's defenders became the hunted. The Luftwaffe called this new phase the Zerstörung der Jagdwaffe, the destruction of the fighter arm. It was not an exaggeration. Losses mounted not just in aircraft, but in men, irreplaceable veterans trained since the 1930s. Every Mustang over Europe represented a strategic shift, from defensive attrition to offensive dominance. It was no longer about surviving a mission. It was about eliminating the Luftwaffe altogether. The engineering philosophy angle at Rechlin, beyond technical admiration, there was something deeper, a recognition of difference in philosophy. German aircraft design, particularly under the influence of Ernst Heinkel and Willy Messerschmitt, was driven by pursuit of peak performance, often at the cost of practicality. Engines were finely tuned, aircraft structures lightened to the edge of fragility, maintenance procedures complex. A single Me-109 might outperform a Mustang in a short, high-altitude climb. but only if handled by an expert pilot with a fully functional, carefully serviced engine. The American approach was holistic. The Mustang's systems were designed for mass reliability. The cockpit layout was intuitive, the landing gear sturdy. The engine could tolerate lower-octane fuel, extreme cold, or field repairs. It was an aircraft built to fight every day, not merely to shine in test conditions. The Germans had once led the world in mechanical refinement, but their industrial model, fragmented, overstretched, and increasingly under siege, could not match this consistency. When the engineers compared machining tolerances between the Merlin and the DB605, they found no great leap in theoretical design. Both were excellent engines. But the Packard-built version showed a degree of standardization Germany could only envy. It represented not a technological gap, but an industrial civilization gap. The more the Germans studied the Mustang, the more it reminded them of something they had lost long before. Not their skill, but their stability, and as they closed their technical reports, the hum of Allied bombers could be heard in the distance, a sound that was now constant, unending, and unstoppable. 4. The human angle for the Luftwaffe pilots who had once ruled the skies. The arrival of the P-51 Mustang felt like the closing of a long, dark curtain. By 1944, many of Germany's finest aces and men like Adolf Galland, Erich Hartmann, Walter Krupinski, and Heinz Baer had survived hundreds of sorties. They were hardened, skilled, and deeply loyal to the idea that mastery of the air could still turn the war. But when the Mustangs appeared, even the veterans sensed a change that went beyond tactics. Hartmann would later recall that seeing the sleek silhouette of the Mustang meant something different from facing a Spitfire or Thunderbolt. The P-51 didn't simply fight well, it seemed to own the sky. Its presence high above the bomber streams meant there was nowhere left to climb, nowhere left to ambush. German pilots began to describe a new fear, the endless pursuit. The Mustang's endurance allowed it to follow an enemy all the way to the ground. Once engaged, there was no outrunning it. The 109 could dive, but the Mustang could dive faster. The 190 could roll, but the Mustang could recover quicker. Many Luftwaffe flyers who returned from those encounters carried an unfamiliar weight. Not the shock of defeat, but the sense of inevitability. The war they had once fought on daring and skill had become a war of systems and numbers. For the young replacements flying their first missions, it was worse. They were outnumbered, outtrained, and outgunned. Against the P-51, their odds were measured not in victories but in minutes. One German ace put it simply after the war. We were fighting men who could afford to learn through mistakes. We could not. The industrial angle inside Germany, the reality of total war, had crippled the one thing the Reich had once prided itself on: its ability to produce. By 1944, Allied bombers were targeting aircraft factories, ball-bearing plants, oil refineries, and transport hubs with relentless precision. The Luftwaffe's production figures looked impressive on paper, but in practice, many aircraft never reached the front. Fuel shortages left wings grounded, and replacement parts were scarce. The United States, by contrast, had turned aviation into an industrial miracle. The Packard Motor Company produced thousands of Merlin engines with remarkable reliability. North American Aviation could roll out multiple Mustangs a day from its Inglewood and Dallas plants. The British supplied technical refinement. The Americans supplied sheer volume. What the Germans discovered while studying the captured Mustang was not just superior craftsmanship. It was the proof of an entire war machine, functioning without interruption. In the Reich, factories were buried under rubble, workers drafted or displaced, resources diverted into countless experimental programs. Jet aircraft, rocket fighters, wonder weapons, each promised salvation, but each drained the system further. The Mustang, in its simplicity, embodied the opposite philosophy. It did not chase fantasy, it perfected what already worked. For every Me-262 that might one day take to the sky, the Allies could field 100 Mustangs, all flying today. That equation, the German engineers knew, was fatal. As one Luftwaffe staff officer later wrote, "We could build marvels, but they could build victory." The moral and strategic angle, the WWII story of the Mustang's discovery inside Germany, is not just about machinery, it's about realization. When those engineers stood around the open Merlin engine, their notes and cameras recording each detail, they were not only analyzing metal, they were confronting a truth about their nation's fate. The Mustang represented more than superior technology. It represented organization, cooperation, and unity of purpose, things that had long since decayed within the Third Reich. Germany's aircraft industry was divided among competing firms and personalities, each jealously guarding influence. Political interference dictated design. Production was splintered by bureaucracy and fear. In contrast, the Mustang was born of coordination between allied nations. An American factory building a British engine to protect bombers attacking German targets. It was the physical proof of what the Axis could never replicate: collective strength. The Luftwaffe's engineers, in their final reports, did not write of despair or surrender. They wrote of respect. They acknowledged that the Mustang was the complete weapon, a machine whose power was magnified by the system that produced it. That was the moral blow. By the time those reports reached Berlin, the Allies were already at the edge of victory in the air. No amount of genius could compensate for a nation running out of fuel, pilots, and time. And as the engineers packed up their tools, the thunder of Allied bombers returned overhead, a sound that no technical report could silence. It was no longer a question of how Germany could win. It was only a question of how long it could endure. From this point, the war in the air would reach its decisive breaking point, not in the laboratories, but in the skies themselves. The hangars at Rechlin were silent that morning, except for the echo of tools and the faint hum of auxiliary power carts. The captured P-51 Mustang, now polished clean and reassembled, stood ready for flight testing. German test pilot Hans-Werner Lersche, a man who had flown nearly every captured Allied type, from the Spitfire to the P-38, was briefed for the mission. His orders were simple: test the aircraft's limits, record data, and identify weaknesses. But as Lersche approached the Silver Fighter, he already sensed what the engineers had quietly admitted: there might be none. The mechanics rolled the Mustang onto the runway. Its propeller blurred into motion, the Merlin engine roaring to life with a smooth, throaty power that filled the airfield. No smoke, no vibration, no roughness. A controlled fury that contrasted sharply with the temperamental German engines they were accustomed to. As the aircraft lifted off, it climbed effortlessly into the pale sky. Lersche noted the stability of its takeoff, the precision of its control surfaces, the almost uncanny steadiness of its roll. At 20,000 feet, he pushed it into a dive. The airspeed needle climbed past 450 miles per hour. Still stable, still responsive. No buffet, no compressibility shock. Back on the ground, his debriefing was brief and sober. The Mustang, he said, has no serious faults. It performs as advertised, and then some. The engineers listened in silence. They had compared its supercharger system to that of the Daimler-Benz DB605 and Junkers Jumo. 213, engines that powered Germany's best fighters, the Bf-109G and FW-190D. On paper, the German units were competitive, even superior in raw efficiency at certain altitudes. But the difference lay in sustainability. The Merlin's two-stage supercharger, integrated with an intercooler and automatic boost control, maintained consistent performance across altitudes. The German equivalents required constant manual adjustment and were sensitive to fuel quality, a growing problem in a nation running on synthetic substitutes. Even more revealing was the cooling system. The Mustang's radiator, mounted in the ventral scoop beneath the fuselage, used the Meredith effect, turning exhaust heat into added thrust. To the German analysts, it was a work of art in thermodynamics. Efficient, elegant, and almost maintenance-free. The Luftwaffe's engineers had long debated whether to pursue high-efficiency fighters or rugged, mass-producible ones. The Mustang showed that both goals could coexist. If a nation possessed the means to execute them, each inspection deepened the unease. The landing gear mechanism was simple and reliable. The radio and oxygen systems were robust and standardized. Even the instrument panel, clear, functional, and identical across units, reflected a level of ergonomic thinking missing from many German cockpits. Then came the production analysis. The metalwork of the Mustang's skin astonished the metallurgists. The panel joints were flush, the rivets precise. There were no unnecessary seams or warps. The surface smoothness alone accounted for measurable performance gains. When they compared it to late-war German aircraft, hastily assembled in underground factories by untrained labor, the difference was humiliating. Reports from the testing center began to read like obituaries. One stated plainly, "The American fighter represents a synthesis of aerodynamic efficiency, production quality, and engine reliability, which exceeds that of current German designs. Its superiority in range and operational readiness renders interception strategy ineffective." The findings were passed up the chain of command. Some Luftwaffe officers refused to believe them. Others, especially those with engineering backgrounds, understood immediately what it meant. Germany's defeat in the air was not the result of a single aircraft. It was the inevitable outcome of an industrial war they could no longer fight. Even so, the engineers completed their work with professionalism. They disassembled and documented the Mustang down to its smallest bolt. They studied the laminar flow wings with contour gauges, measuring the exact curvature, searching for flaws that did not exist. In one final test, they measured the Mustang's cruising fuel economy and endurance. The data confirmed what combat pilots already knew. It could escort bombers deep into Germany and still have power to fight. The Luftwaffe had no equivalent. The numbers told a simple truth. Germany's last tactical advantage was gone. That evening, as the test crews packed their instruments, the sound of distant engines rumbled overhead. Allied bombers, escorted by Mustangs, were crossing toward Berlin. The men at Rechlin stepped outside to watch. Their own flak guns opened fire in the distance, tracers arching upward against the clouds. Above them, faint silver glints moved in formation. The very machines they had just examined, now returning to finish what they had begun. The engineers stood in silence, the realization complete. The war's turning point had not come from a single battle or a new weapon. It had come from understanding, and knowing they could never match it. By the spring of 1944, the impact of that realization was visible across every front of the air war. From the airfields of East Anglia, the 8th Air Force launched massive bomber raids, Schweinfurt, Brunswick, and Berlin, escorted by P-51 Mustangs stretching from horizon to horizon. The American pilots who flew them were young, confident, and now, at last, no longer flying into slaughter. The Mustang gave them what no other escort had before: endurance, reach, and dominance. On March 4, 1944, the first fully escorted raid reached Berlin. Not one bomber was lost to enemy fighters. For the Luftwaffe, it was a day that shattered the illusion of defense. For the engineers at Rechlin, it was the proof of their own reports played out in fire and contrails above the capital. Every attempt to counter the Mustang ended in tragedy. The new Bf-109 G10s and FW-190 D9s, the so-called high-altitude answers, were fine machines, but they burned scarce fuel and relied on pilots the Reich could no longer replace. They might win an engagement, but never the campaign. The Luftwaffe tried new tactics: massed frontal attacks, rocket-armed intercepts, even the desperate Sturmgruppen formations, heavy armored fighters meant to smash through bomber streams. Yet each wave met the same fate: Mustangs sweeping in from altitude, tearing into the attackers before they could reach their targets. The Mustang's pilots flew with deadly efficiency. They no longer fought defensive battles, they hunted. Their orders were clear: destroy the Luftwaffe wherever it rose to meet them. In February and March 1944, during Operation Argument, known to air crews as Big Week, the 8th and 15th Air Forces launched coordinated raids on Germany's aircraft factories. Mustang escorts followed them every mile of the way. For the first time, Allied bombers struck at the heart of the German aviation industry and came back largely intact. The results were devastating. In 1 week, the Luftwaffe lost nearly 1/3 of its remaining fighter force. More critically, it lost its veteran corps, the men whose experience had kept the system functioning. The engineers at Rechlin received the casualty figures as they were finalizing their Mustang report. The numbers read like a confirmation of everything they had discovered. Technology alone could not win a war, but mastery of production, Organization and endurance could. By summer 1944, the transformation was complete. The skies over France and Western Germany belonged to the P-51. During the Normandy invasion in June, Mustangs patrolled over the beaches from dawn to dusk, cutting down German aircraft before they ever reached the front. Even the introduction of the revolutionary Me-262 jet fighter, faster than any propeller aircraft in the world, came too late. When the jets took off, they were slow and vulnerable, easy prey for Mustangs circling above their bases. The airfields at Lechfeld and Neuburg became death traps. German ground crews began calling the American fighters Todesengel, angels of death, for their habit of appearing silently, then diving out of the sun. At Rechlin, one senior engineer wrote a final memorandum. His words were measured but clear. The Mustang represents not only the technical maturity of our opponents but the completeness of their system. It unites design, production, and logistics into one decisive weapon. Against such integration, isolated brilliance cannot prevail. The report was forwarded to Berlin but changed nothing. By autumn, the Luftwaffe's fuel reserves were collapsing, its airfields bombed, its pilots exhausted. The once mighty air arm that had terrorized Europe in 1940 was now a ghost force. Still, the engineers continued their work with grim professionalism. They tested captured P-47s, P-38s, even a B-17. But none carried the same weight as the Mustang. It was the symbol of the new era, the triumph of sustained, coordinated warfare over improvisation and ideology. As 1945 began, Allied fighters roamed unchallenged across Germany. They strafed rail lines, convoys, and retreating columns. The Luftwaffe barely rose to meet them. When they did, the result was predictable: a few minutes of combat followed by silence. The reports from Rechlin grew shorter. By March, the facility itself was under threat of bombing. Many of its archives were burned or evacuated, but fragments survived: pages of technical notes, engine sketches, performance graphs, and the terse handwritten line found in one engineer's logbook: "No further improvements will change the outcome." It was not surrender. It was acknowledgement. For those who had opened the Mustang's engine cowling and peered into its gleaming machinery, the realization had been slow but absolute. Germany had entered the war believing its engineering genius could overcome any odds. The Mustang proved that genius without endurance is only brilliance in isolation. And as the engineers left their hangars for the last time, they could still hear the distant hum of aircraft, Mustangs, flying toward Berlin. The war they had tried to understand had already passed them by. By the time the Allies crossed the Rhine in March 1945, Germany's skies had fallen silent. The Luftwaffe, once the spearhead of Blitzkrieg, was now a shattered force, its aircraft scattered, its pilots dead or captured, its airfields blackened ruins. The P-51 Mustang had done what no single weapon had achieved before. It had erased the Luftwaffe from the air. The transformation had been as much psychological as physical. The Mustang was not just a fighter. It was a statement of inevitability. Each squadron that lifted from English soil carried with it the industrial heartbeat of an entire nation: American steel, British design, Canadian fuel, global coordination. Against that, the fragmented machinery of the Reich simply could not compete. In early 1945, German aircraft production still produced numbers on paper, but most were useless. The Me-262 jets, hailed as the miracle weapon, were grounded by lack of fuel and airfield security. The FW-190D9, perhaps the finest piston fighter Germany ever built, appeared in too few numbers to matter. Even when they took off, Mustangs were waiting above the clouds. The statistics told the story better than any speech could. In 1944 alone, the Luftwaffe lost nearly 28,000 aircraft, almost its entire frontline strength, while Allied losses steadily declined. The 8th Air Force, once mauled in daylight raids, now flew with impunity. Bomber formations reached Berlin, Dresden, and Munich with precision unheard of in earlier years. For Germany's engineers, the post-mortem had already been written months earlier. The reports from Rechlin circulated quietly among surviving technical officers. Many recognized that their nation had reached a point of no return long before the bombs fell on Berlin. The Mustang represented what they could no longer achieve: balance between innovation and production. While the Luftwaffe's late war designs reached breathtaking levels of sophistication, Jet engines, swept wings, rocket propulsion. They were trapped in an ecosystem that could no longer sustain them. Factories were decentralized and starved of materials. Skilled labor was replaced by prisoners and forced workers. The technical brilliance of the Me-262 or Ta-152 was meaningless without fuel or maintenance. By contrast, the Mustang thrived in a system that worked seamlessly from blueprint to battlefield. Engineers, logisticians, and pilots were part of one unbroken chain. Replacement parts arrived before they were needed. Pilots trained in abundance. Every squadron could be kept at full strength. The result was cumulative dominance, quiet, relentless, and final. In the final months of the war, Mustangs flew ground attack missions across central Germany, targeting locomotives, convoys, and retreating Wehrmacht units. Their pilots, once bomber escorts, now became the executioners of Germany's war machine. Airfields were strafed daily, bridges destroyed before retreating columns could cross. Even the great German armored formations, once symbols of unstoppable force, were rendered helpless under the unbroken watch of Allied air power. To the engineers who had once examined the Mustang in quiet awe, the sight was bitterly ironic. The very aircraft they had studied in detail was now part of the storm that erased their world. By April 1945, the Rechlin test center itself was abandoned. Allied bombers had hit the facility weeks earlier, and what remained was overrun by Soviet forces soon after. The captured P-51, meticulously studied, was either destroyed or taken east as a war prize. Its remains, if any, were lost in the chaos of Germany's collapse. Among the surviving engineers, a few were later recruited into post-war programs, some by the Americans under Operation Paperclip, others by the Soviets. They carried with them the lessons of those final months, that victory in modern war was not won by isolated brilliance, but by integration, endurance, and scale. The P-51 Mustang was not just the better fighter. It was the visible proof that the era of total war had entered a new dimension, one where the battlefield began in the factory. And for the men who once opened that engine cowling, that truth would haunt them long after the war was lost. When the war finally ended in May 1945, the shattered remains of the Luftwaffe lay scattered across Europe, rusting aircraft in fields, half-finished prototypes in tunnels, stacks of abandoned blueprints in underground factories. The air arm that had once carried Hitler's ambitions had ceased to exist. For the Allied pilots who had flown the Mustang, victory came not as celebration, but exhaustion. They had fought continuously for over a year, their missions stretching from the beaches of Normandy to the heart of Germany. Yet the results were undeniable. By the time the Third Reich surrendered, the Allies controlled the air absolutely. For the engineers who had examined the Mustang at Rechlin, defeat carried a strange duality. Professionally, many of them admired what they had seen. The Packard-built Merlin engine was a masterpiece of coordinated engineering, a balance between refinement and practicality that mirrored what German engineers themselves had once aspired to. Yet personally, it was an admission that Germany's technical prestige, once its proudest export, had been overtaken. In the ruins of Berlin, surviving Luftwaffe officers and scientists were divided among the victors. American and Soviet technical intelligence teams scoured the country, gathering whatever remained of German research. Among the documents recovered were detailed evaluations of captured Allied aircraft, including the full analysis of the P-51 Mustang conducted at Rechlin. The Americans who reviewed those reports were struck by their tone. There was no arrogance, no denials, only quiet, methodical respect. The German engineers had understood exactly what made the Mustang successful. They simply no longer had the means to emulate it. In the following years, many of those same engineers contributed to a new era of aviation. Some worked on early jet and rocket research for the United States. Others assisted in Soviet design bureaus, where lessons from Allied and Axis technology were fused into the next generation of fighters. Their wartime discoveries did not vanish. They became part of the foundation for post-war aerospace development, from the Sabre jet to the MiG-15. In each, the echoes of that wartime realization remained. The value of simplicity, endurance, and balance over excess innovation. The Mustang itself became immortal. Though built for war, it survived to serve in Korea, Israel, and countless smaller conflicts, restored Mustangs still fly today, their Merlin engines still roaring with the same unmistakable tone that once filled the hangars of Rechlin. For many veterans, that sound represents not just victory, but the transition of air power from instinct to engineering. In Germany, the legacy of the Mustang took on a quieter meaning. Among the few surviving Luftwaffe pilots, there was no shame in acknowledging its superiority. Adolf Galland, reflecting years later, said, "The Mustang was the best all-around fighter of the war. The day it appeared in our skies, the air war was lost." The men who had once studied that captured aircraft had reached the same conclusion long before Galland's words. For them, the realization came not through combat, but through observation, through the precision of a gear assembly, the contour of a wing, the uniform gleam of a machine built by a nation with limitless resources and singular purpose. They had seen, in mechanical form, the future of warfare, a future where mastery of process mattered more than inspiration alone. When the last test reports were archived and the facility at Rechlin fell to ruins, one page remained unclassified for decades. At its bottom, written in careful script, was a final note. The aircraft is technically superb and reflects the total capability of its creators. Against such an enemy, the war cannot be won by bravery or design alone. It was both an epitaph and a prophecy. The Mustang had ended more than Germany's air supremacy. It had ended the age when craftsmanship alone could shape victory. From that point onward, the power of nations would no longer rest on the genius of individuals, but on the system that could sustain them. When the war finally went silent, the echoes of engines faded into memory, but one sound remained, etched into history, the rising hum of a Merlin engine at full song, steady and unbroken. The P-51 Mustang was more than a machine of metal and fuel. It was the physical embodiment of an idea, that technology, when guided by strategy and supported by system, could change the course of nations. For the German engineers who once stood around that open cowling, their discovery had been humbling, even haunting. They had spent years believing that perfection in design was enough, that precision and innovation could overcome any obstacle. Yet in the polished aluminum of the Mustang, they saw something different. Not perfection, but integration. A unity between invention, production, and purpose. That was the true revolution of the Mustang. It was not just faster or farther. It was complete. It was what happens when every gear, every worker, every engineer, and every pilot move toward a single goal: victory through endurance. In the decades that followed, every modern fighter, every aerospace project, carried a fragment of that lesson. From the jet age to the space race, the story of the Mustang lingered as both inspiration and warning. Brilliance must be scalable, and war rewards not the cleverest idea, but the one that can endure. For those who walked away from Rechlin in 1944, the truth was written not in reports, but in the sky above them, contrails stretching endlessly east, toward a future they could no longer touch. The day the German scientists examined the P-51's engine was not just a study in engineering. It was the moment they looked into the machinery of the modern world and realized that history had already chosen its victor.